Hi everyone, how are you all? I hope you are good. Today we will be solving the question valid anagram. So let's see what is this question. Given two strings S and T, return true if T is an anagram of S and false otherwise. We are given with two strings S and T and we need to return true if T is an anagram of S and false otherwise. So what is an anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So, what is the anagram? Anagram is basically a word or phrase like you are given with a word anagram. Okay, and by arranging its letters only, if you can form another word, then that word is an anagram of this word. Okay, you get, I hope you get it. Like, what is anagram? If you form some other word by arranging the characters of a word only, then they both are anagrams of each other. It means you can't add any other character in it or can't delete any character from that word. You can just rearrange the characters of that word and form a new word. Okay, so we need to return whether S and T are anagrams of each other or not. So how we can find that? Like we are given with this string and this string. And we need to find that whether T is formed by arranging the characters of S or not. Okay. So one very basic approach for this question could be like if we sort both these strings. Okay. So then the characters in this string will be arranged in an alphabetical order. And if both these strings are equal, then they are anagrams of each other, otherwise not. Okay, so one very basic approach for this will be by sorting. Okay, so and the base condition, if we can also apply a base condition like if the length of both the strings are not equal, then they can't be anagrams of each other because we have used either we have used extra character or either we have deleted some character. That's why their length are not equal. So let's try code this approach. Then we will move on forward. If their length is not equal, then we will return false because they can't be anagrams of each other. Okay. So first of all, we will sort string S and then string T. Sorry, S dot begin till S dot end, and now we will sort string T. And now if they are not equal, then they can't be anagrams of each other, so return false. Otherwise return true. It means they are anagrams of each other. So let's try run this code. Yeah, it's working fine. So now let's talk about its time and space complexity. So it's as we are sorting these strings. So it's the complexity for sorting will be n log n, n log n. And we another complexity will be used in this sorting. So it will be plus n log n. Okay. So we can say 2 into log n or basically we go of n log n. Okay. Because 2 is a constant. Now talk about its space complexity as we are not using any extra space. This space complexity will be big of 1. Okay, cool. Now this n log in complexity is not looking good. Can we reduce it further? Let's see what we can do. We just need to find whether T is formed by arranging its character or not. Okay, let's see how we can do it. Okay, so we have two strings. So if we store the count of characters of S in a map and then compare it with T, so I think we be able to reduce its complexity. Let's see how. So the count of A in is 1. The count of N in S is 1. The count of G in S is 1. The count of R in S is also 1. M in S is 1. Okay, cool. So now we will start iterating this string. Okay, and reducing the frequency of that character in this map. Okay, let's see. Now we are at n. The count of n, yeah, n is present in this map, and its count is also greater than 0. So we will reduce it by 1. So it will become 0. Now we are at a. Yeah, a is present in this map. So we will reduce its count. Now we are at G. Yeah, G is also present in this map. Okay, we will reduce its count. Then A again. Yeah, A is present in this map. We will reduce its count. Yeah, R. Yeah, R is also present in this map. We will reduce its count. Again, A. Yeah, A is present in this map. We will reduce its count. M. Yeah, M is also present in this map. So we will reduce its count. Okay, so yeah, in this way we have reduced the count and we don't get any condition when the T is not an anagram of S, because if the character in this string is not available in the map, then T is not an anagram of S. Or if the character is present but its frequency is 0, then it is not an anagram of S. Okay, so now let's see another case when S is equals to rat and T is equals to car. Okay, so let's see for this. Now we will create a map. The count of I will be 1, A will be 1, and T will be 1. Okay, now we will iterate string T. We are at C. Oh, C is not present in this map. It means T can't be anagram of S, so we will simply return false. So I hope you get this intuition. So let's try code this. So base condition will remain same because if their lengths are not equal, then they can't be anagram of each other. Okay. So first of all, we will create an unordered map of character comma int, and we will store the length of s in int. And now I will iterate in s for storing the frequency of its character in map. Okay. Now I will iterate in T for checking whether that character is available in the map with frequency greater than 1. So if map.find T of I equals to map.end, it means that character is not present in map. Or if the frequency of that character present in the map is 0, it means that character is no more present in S. It means that T is not an anagram of S, so we will finally return false here. But if we have never encountered this condition, so we will simply decrement the count of that character in the map and finally iterating the whole string. And if we did not encounter this condition anywhere in our loop, so at the end we will return true. It means T is an anagram of S. So let's try run this. Yeah, it's working fine. Let's try submitting this. Yeah, cool. So now let's talk about its time and space complexity. Talking about its time complexity, we are running this one loop for iterating the S. We are running this another loop for iterating the T, which is big O of 1. And for finding and inserting in the map, it will be big O of 1 in a best in average case, as we have created an unordered map. So I can say that its complexity will be big O of n plus n for this loop. So its overall complexity will be big O of n. And talking about its space complexity, we have created a map which will store only 26 characters, as we have 26 characters only. So which is also a constant. So we can say that its time space complexity is big O of 1, which is also a constant. Okay, so I hope you get this question. If you still have any doubts, you can post in the comment section. I will surely answer them. So see you soon, guys, with the next video. Till then, bye bye.